Question number 8. A body can be negatively charged by giving excess of electrons to it, removing some electrons from it, giving some protons to it, or removing some neutrons from it. Let us discuss in detail. Okay. So first one, whenever a body is given excess number, first of all, let us consider a neutral charged body. Neutral charged body means it may having equal number of protons as well as electrons. If equal number of positive charges as well as negative charges are kept present, then we say that the body is uncharged. So to this body, whenever excess electrons are being given, then what happens? So these gets nullified. So we clearly observe that 1, 2, 3 excess number of electrons are present. Okay. So when excess number of electrons are present, the body will be negatively charged. So giving excess, so body can be negatively charged by giving excess amount of electrons to it. Okay. Well, moving to the next question, numerical part. The minimum charge on an object is, so whenever you give an object or a body, the minimum charge that can be possible on the body, is it 1 coulomb, 1 stat coulomb, 1.6 into 10 power minus 19 or 3.2 into 10 power minus 19. Children, you know that the charge, okay, Q is given by NE. Charge is given by Ne, whether it is plus or minus Ne, magnitude we are not bothered, how many electrons are there. So electrons are free to move anywhere. At least if one electron moves, then at least one electron is there on a body, then we say that the charge on the body is approximately equals to 1 into 1.6 into 10 power minus 19 coulombs. Hence it is equals to 1.6 into 10 power minus 19 coulombs. For every one electron deficiency or addition of electron, it may gain or lose 1.6 into 10 power minus 19 coulomb. So the minimum charge that can be given to an object is 1.6 into 10 power minus 19. This will be double that, not 2. Minimum they are asking. So only one free electron based on that. Hence, the correct option is option C, that is 1.6 into 10 power minus 19 coulombs. Okay. So, now moving to the next one, 10th question. The number of electrons in 1 coulomb of charge will be. So, what is there? So, number of electrons. We know the formula for Q is equals to plus or minus Ne. Okay. Here, magnitude is only considered. So, you need to consider its symbol. So, Q is equals to Ne. They didn't indicated any plus or minus symbol, simply Q is equals to Ne. Where Q is the quantity of charge that is present and number of electrons, and E is the charge of each electron. So, as you are asked to find the number of electrons, the value of N can be given as Q upon E. So, how much the value of Q is given as 1 coulomb. So, given that the value of Q they have given, so you are asked to find the value of N, and the value of Q they have given it as 1 coulomb. Substituting in the above equation, we have Q is replaced with 1 coulomb and the charge of electron is 1.6 into 10 power minus 19 coulombs. So, 1 coulomb upon 1.6 into 10 power minus 19 coulombs gives here 1 by 1.6 into 10 power plus 19 or 10 upon 16 into 10 power 18. So, after simplifying this, we find that this goes 5 times and this goes 8 times. Hence, the value of number of electrons is found to be 0.100. 10 power 19. So multiplying and dividing with 10. 1 into 10 is 10. 1.6 into 10 is 16. So 10 upon 16 is a little difficult value, but still let me consider this goes 8 times and this goes 5 times. 5 upon 8 into 10 power 19 is found to be 0.48. 16 5s are 40 into 10 power 19. So 0.625 into 10 power 19 can also be written as 6.25 into 10 power 18. So the number of electrons that are present in 1 coulomb of charge is found to be 6.25 into 10 power 18 electrons. Hence, option B must be true. So now moving to the next question, 11th one, charge of an alpha particle. We have already discussed that the charge of an alpha particle is nothing but charge of an helium particle. So alpha particle is nothing but your helium. The atomic number of helium is 2 and the mass number is found to be 4. So it asks you to find the charge of an alpha particle. So charge of an alpha particle Q is given as number of electrons. So how many number of electrons are there here? 2. N is the number of electrons. Number of electrons is atomic number 2 indicates it consists of 2 electrons and 2 protons. Okay. So the number of electrons is taken as 2 and the charge of each electron is 1.6 into 10 power minus 19. So after simplifying you get the value as 3.2 into 10 power minus 19 coulombs. Hence the charge of electron is found to be 3.2 into 10 power minus 19 coulombs. So third option must be true. So moving ahead with the next question, 12th one. When a glass rod is rubbed with silk. So when we see that whenever a glass rod is rubbed with silk cloth, we observe that the glass rod attains positive charge whereas the silk rod obtains negative charge. So what does it mean? So whenever a glass rod attains positive charge, it implies that it loses some amount of electrons. By losing some amount of electrons, it attains positive charge. Whereas the silk, while gaining some amount of electrons, it becomes negatively charged. Okay. So when a glass rod is rubbed with silk, then it in the sense glass rod gains electrons from the silk, gives electrons to the silk or protons. We are talking about only electrons will be in motion, not the protons. So it loses its electrons to become positively charged. Hence the correct option is option B, that is gives electrons to silk. Okay. So now moving to the next one, dielectric constant for metal is. So dielectric constant I already told you that indicated with the letter K. Okay. So for a metal the dielectric constant is always infinity. For a metal it all depends upon the number of charges that are present. So metal, the dielectric constant of a metal is always infinite. So infinite number of charges can be there. Okay. Hence it is a good conductor. When a body is earth connected, when a body is connected to the earth, grounded, electrons from the earth flow into the body. So whenever you consider a body and this body which is earth connected, then clearly we say that it was said that electrons from the earth flow into the body. Let us consider this is an uncharged body. So whenever electrons flow inside the body, then what happens? The negative charge on the body increases. Whenever the negative charge on the body increases, then the body becomes uncharged, positively charged, negatively charged, or an insulator. So no doubt the body will become a negatively charged. Okay. The body is negatively charged. Break. ఎగిరిందా ఏంటి అర్థమవుతుంది. నెగిటివ్లే చూపించట్లేదు. Earth connected electrons from the earth flow into the body. Electrons. Okay. Wrong ఎందుకు చెప్పానా? మిస్టేక్ వచ్చింది. Repeating. So moving to the next question, children, 14th one. When a body is earth connected, electrons from the earth flows into the body. What does this mean? Children, why does an electron move to the body? So whenever a body has a deficiency of electrons, it accumulates electrons. Electrons get transfers into the body. So whenever a body has a deficiency of electrons, it indicates the body is positively charged. Okay, to neutralize itself, so electrons are being moving inside the body. So always electrons get attracted towards a positively charged body. So clearly, when a body is earth connected, electrons from the earth starts moving inside the body. So that means electrons get attracted to the body. It implies that the body is positively charged. So the body is charged positively. Hence option B must be true. In the latter case, suppose if the electrons moves inside the ground, that means the body will be having excess number of free electrons, hence they are moving inside the earth. So in this case, excess number of electrons means the body will be negatively charged. That is the second case. Okay, so clearly, as the electrons are attracted by the body, it indicates that the body is positively charged. So now moving to the next question, 15th one. The number of electrons in 1.6 coulomb of charge will be. So the same formula, children, we know that Q is equals to NE, or the value of N can be given as Q by E. So, and here it was given that the number of electrons in 1.6 coulomb. So, where Q is given as 1.6 coulomb and the value of E, we know it as 1.6 into 10 power minus 19 coulombs. So, substituting these values in the above equation, we get Q is 1.6 and E is 1.6 into 10 power minus 19. So, simplifying further, 1.6 and 1.6 gets cancelled. Hence, your answer is 10 power 19. So, how many electrons are supposed to be present on the body? 10 power 19 electrons. So, now moving to the 16th question, when 10 power 14 electrons are removed from a neutral metal sphere. How many electrons are removed? The value of N, number of electrons that were removed, are given as N is equals to 10 power 14. Are removed from a neutral metal sphere, the charge on the sphere becomes, okay. So, charge on the sphere means you're asked to find that value of Q. So, clearly the value of Q is equals to NE, okay. So, regarding the positive charge and negative charge, we shall discuss later. First of all, let us find out the magnitude of the charge. Number of electrons is given as 10 power 14 and the charge of each electron is given by 1.6 into 10 power minus 19. So, simplifying this, we get 1.6 into 10 power plus 14 minus 19 is minus 5. Okay. So, here multiple of 16 is there. So, it can also be written as decimal. Okay. Decimal, if it is removed, means 16 into 10 power minus 1. Okay. So, or else I'll write it as 16 by 10 is nothing but 1.6 into 10 power minus 5, or 16 into 10 power upward means minus 1 into 10 power minus 5. Hence, it is equals to 16 into 10 power minus 6. Minus 5 minus 1 is minus 6. So, hence, it is equals to 16. 10 power minus 6 can be written as microcoulomb. Okay. So, what is the charge of electron? The charge of electron is found to be 16 microcoulomb, but we are not clear whether it is a plus 16 microcoulomb or minus 16 microcoulomb. So, to consider whether it is A or B, let us discuss in detail now. There is, so it may be option A or option B might be true. So, 10 power electrons are removed from a neutral metal sphere. The charge on the sphere becomes, earlier the sphere was neutral, uncharged. Okay. Now, whenever, so uncharged means it consists of equal number of positive charges and negative charges. Now, what they are doing is, when electrons are removed from the body, so less number of electrons, more number of positive charges. So, now the body is positively charged after removing the electron. Okay. Hence, the correct option is positive 16 microcoulomb. Hence, option A must be true. Okay. So, now moving to the next question, 17th one. A conductor has 14.4 10 power 9 minus 19 coulombs. So, what is the charge, children? The charge of the conductor is given as 14.4 into 10 power minus 19 coulombs. The conductor has, and it is also given as positive charge. Okay. How many electrons? As we know, the formula for Q is equals to Ne. Okay. Or since the formula for Q is equals to Ne, this implies that the number of electrons is equals to Q by E. 14.4 into 10 power minus 19 upon 1.6 into 10 power minus 19. These two gets cancelled. Hence, you are left with 14.4 upon 1.6. So, 14.4 upon 1.6 multiplying throughout with 10. 14.4 into 10 will become 144. 1.6 into 10 will become 16. Okay. So, now 16 multiplied by 9, 144. Hence, after further simplification, we'll get the value as 9. So, what is the charge of this? So, number of electrons, we found the number of electrons is 9 electrons. Number of electrons is 9. So, now we are asked to find out whether 9 electrons are excess in number or 9 electrons are shorter. Okay. So, what is doing? Coulomb of conductor has 14.4 10 power minus 19 coulombs positive charge. What is the charge? Positive charge. When it is a positive charge, it has large number of positive charges and less number of negative charges. So, it has a shorter number of electrons. So, how many shorter electrons are there? 9 electrons are in short. The reason why, as there are less number of electrons, the body is positively charged. Hence, the correct option is option D, that is 9 electrons in short. Okay. So, now moving to the next question, that is 18th question. When 10 power 19 electrons are removed from a neutral metal plate. Meaning of neutral metal plate means uncharged body. So, when 10 power 19 electrons are removed from a neutral metal plate, the electric charge on it is. So, let us see in detail. Electrons are removed. So, neutral body is there. Okay, from neutral body, equal number of positive and negative charges, electrons are removed. When electrons are removed, this body has a deficiency of electrons. So, it will become positively charged. Okay, so metal plate, the electric charge on it is positive. No doubt that will become positive. How much positive electrons? Let us try to find out. So, to simplify this, electric charge Q is equals to Ne. Okay, as we have just discussed that it will gain a positive charge plus Ne, or Q is equals to how many number of electrons? N is given as 10 power 19, and charge of each electron, as we know that 1.6 into 10 power minus 19. Hence the value of Q is found to be 1.6 coulomb plus 1.6 coulomb. Hence, the correct option is option B, that is 1 plus 1.6 coulombs. That's it. Let me write it clearly. Plus 1.6 coulomb. Well, so let us move to the next question, children. This is 19th question. A body has minus 80 microcoulomb of charge. So, given the value of Q as minus 80 microcoulomb, the number of additional electrons in it will be. So, you are asked to find the number of electrons, the value of N. So, the value of N is equals to, since the value of Q is equals to Ne, it indicates that the value of N is equals to Q by E. Charge is given as 80 microcoulomb upon the charge of electron is 1.6 into 10 power minus 19 coulomb. So, here it is measured in microcoulomb and here it is in coulomb. So, simplifying this further indicates 80 into 10 power minus 6 coulomb upon 1.6 into 10 power minus 19 coulomb. So, further simplifying gives 800 upon 16 into 10 power minus 19. When it is brought up, minus 6 plus 19 will become plus 13. It will become plus 13. So, now simplifying this further, you get 8 2s 100, this will go 50 times. So, 50 into 10 power 13. So, here clearly we have 5 into 10 power 14. Hence, the correct option is N can be written as 50 into 10 power 13, or this 1 0 giving to this power, it will become 5 into 10 power 14. Hence, the number of electrons that are present is found to be 5 into 10 power 14. Okay. So, now moving to the next one, question number 20. Okay. Due to the motion of a charge is moving. Due to the motion of a charge, its magnitude changes, does not change, cannot be predicted, increases or decreases depends on its speed, or cannot be predicted. Okay. So, does the motion of a charge, due to the motion of a charge, its magnitude changes or does not change? So, what would be the correct answer, children? Due to the motion of the charge, its magnitude does not change. Whose magnitude? Charge magnitude does not change. So, while it is moving, maybe it is increased with, suppose if you take an electron, when electron is in motion, whether it is moving with high speed, low speed, accelerating, decelerating, constant velocity, whatever be the case, its value will never change. Its value is always 1.6 into 10 power minus 19 coulomb, whether it is moving very fast or slowly. Okay. So, its value will never change due to its motion. Next, induction precedes attraction because. So, induction precedes attraction. Just now we have discussed earlier. So, due to the method of induction, opposite charge is created on the other body. If you consider a positive, if you take a positive charge to an uncharged body, it induces negative charge. Negative charge is induced in the second body. So, body 1. And body 2. Due to the method of induction, opposite charge is induced in the second body. Is clear? Okay. So by the method of induction, induction precedes attraction because an opposite charge is induced in the second body. As a result, when both are opposite charges, no doubt attraction takes place between the two bodies. So induction precedes attraction because an uncharged body can attract an uncharged body. No. A charged body can attract an uncharged body. Of course. A charged body can attract an uncharged body due to induction of opposite charges, or a charged body can attract another charged body due to the induction of same charge on it. Okay. So the correct option is option C. The reason is a charged body can attract an uncharged body. So earlier it was an uncharged body and this was a charged body. So this charged body was attracting an uncharged body due to the induction of opposite charge on it. Why? Because some opposite charge is induced on that body. As a result, they both are getting attracted. Hence, the correct option is option C. So now moving to the next question, 22nd, when charge is given to a body. So to a body, we are giving some charge. More charge accumulates at regions of small curvature. More charges accumulate to the regions of large curvature, which is true. So as we said that, so large amount of charge is accumulated at the sharper edges, whereas less amount of charge is accumulated at the broader edges. So charge is not distributed uniformly. Okay. So what is the correct option? More charge accumulates at the region of smaller curvature, whereas less charge is accumulated at the regions of larger curvature. Hence, the only correct option is first one. So, at the place of small curvatures, we have more large amount of charges been accumulated, more charges accumulated. So now let us move to the last question, children, 23rd. A soap bubble is given a negative charge. Soap bubble is given a negative charge. Then its radius, we have already discussed this. Whenever a charge is given to a soap bubble, okay, due to the repulsion between the like charges, the radius of the soap bubble increases. Due to the property of repulsion, they move away from each other and as a result, its radius increases. So, 23rd option B, that is increases, is the correct option. So, with this we have concluded with the numerical problems from worksheet 1. So, keep practicing. Let us meet in the next session. Until then, take care. Thank you.